Hello, everyone. This is Mrs. Shaw, and today we are going to continue talking about our functions. We've talked about the domain of a function, which is the set of all possible inputs. The domain are our x values. Of course, the other name for that is our inputs, and they are our independent variables. Well, the range of a function is the set of all the possible outputs. Those are our y values. There are outputs. There are dependent variables. But there's another name, another notation we can use for our range, for our y values, and that is f of x. Today we are going to learn how to read and write using this function notation, f of x. What is f of x? It's sometimes looking at it, when we first see it for the first time, it looks like f times x that's in parentheses, and that's not what it is. That's why it can be a little confusing at first, but as we get used to it, you'll actually like using f of x. Think of it as our functions. The x we know is our input. So what goes into the function, the f of x is our function, and then we get our output. So it's a fast way to put these inputs and outputs together. Here we have a set of ordered pairs. All right, so let's do this example. If our function is a set of ordered pairs, let's look at if our input is 1. Okay, we know our input is our x value. So here, right here, we have 1 as our input. So if 1 is our input with this ordered pair, what is our output? Well, we know that our output, when x is 1, our y is 4. So when our input is 1, our output is 4. And how we write it in function notation is f of 1 equals 4. And that's how we say it, f of 1 equals 4. Another example here. If our input is 3, we come up to our function here, and our input, 3, what was our output? Well, when our input for this function here with these ordered pairs is 3, we know our output is 7. So a way to write that, f of 3 equals 7. So here is another set, or here is our set of ordered pairs here, our function, and we want to know what, when our input is 6, f of 6, our input is 6, what is our output? So we come up here to our set of ordered pairs, and our input being our x is 6. What is our output? Well, we can see that that is 8. All right, what if we say f of 8? That's saying when our input is 8, what is our output going to be? We come up to our set of ordered pairs here. Our input is 8. Our output is 5. So another way of writing this ordered pair 8, 5, we can write it as f of 8 equals 5 as our function. Here we have f of 4. So what is if our input is 4, what is our output? We come up here to our set of ordered pairs, looking at all of our inputs. There is not an input that is 4. So for this set of ordered pairs, for this function, if the input is 4, there is no output. It does not exist. D-N-E. All right, next example here. Here, we know our input is our x. Here, for what x will our output be 4? So come up here and look at our function, our set of ordered pairs up here, and where the output is 4, our input was 1, our x equaled 1. Okay, so for where our output is 8, come and look at our outputs. Oh, there's an 8. What is our input? We're wondering, what is our x? What is our input when our output was 8? Well, here's this ordered pair right here, 6, 8. So our x was 6. Our input was 6 when our output was 8. So we've been writing our equations, our y equals 2x plus 3. But now we're going to write it as a function. So y equals 2x plus 3. Now we're going to write as f of x equals 2x plus 3. Our f of x is our notation we're going to be using from now on, and you'll use it a lot at the high school. And here is why that is very, very helpful. So here we have a function f of x equals 2x plus 3. So we're wondering what happens when we put 1 into our function. All right, what are we going to get out? That means if our x is 1, and we would replace all the x's, we would replace with a 1. So what happens when 2 times 1 plus 3? What is our output going to get? 2 times 1 is 2 plus 3. And you're right, we're going to get 5 as our output. So when our input is 1, our output for this function is 5. Another example. What happens to our function if our input is 3? That means we're going to replace our x's are our input. So we're going to replace our x's with the number 3 into our function. Our input is 3. So this x is being replaced by 3. And we're going to have 2 times 3 is 6, plus 3 is 9. So we know when our input is 3, our output is going to, oops, I thought that would be there. Our output here would be 9. Here's another example. What do we get if our input, our x value, is 0? We would replace our x's, oops, I am not the best at writing these. Let me see. I'll just put it right above here. How about 0 there? We're going to replace the x with 0. And remember, that is being multiplied. So f of 0 equals 3 times 0 minus 2. 3 times 0 is 0. 0 minus 2 is negative 2. So our f of 0 equals negative 2. Next example, f of 2. If here's our function, that means we're going to replace a 2. I'll try this again. So we can write this. F of 2, our input is 2. So we're going to replace our x's with a 2. 3 times 2, and then minus 2. So f of 2 equals 3 times 2 is 6. And 6 minus 2 is 4. So f of 2 equals 4. Here's some more examples. And I want you to pause your video and check and see if you can do some of these. And then we'll come back. All right. Hopefully you've had time to practice some of these, and I will see how you did. Or you can see how you did. Check yourself and see how you did with those. We're going to do some more examples here. This one, I'll work through one of them with you here. Let's do our function h of x is equal to 2 times 3 to the x power. Well, let's do this one right here. Let's do when our input is 3. When our input is 3, that means we are going to be writing h of 3 is equal to, we're going to replace up here 2 times 3, instead of the x, we're going to put 3. Okay, now you need to remember your order of operations. Remember order of operations is parentheses, PEMDAS, exponents, multiplication, division, adding, and subtraction. Okay, we need to remember the order of operation. We don't multiply 2 times 3 first. We actually need to do, there aren't parentheses, but there is an exponent. We need to do 3 to the third power. That's 3 times 3 times 3. 3 times 3 is 9, and times 3 is 27. So this is actually going to be equal to 2 times 27. You could also do this on your calculator. And 2 times 27 is equal to 54. So when our function h, when our input is 3, our output is going to be 54. I want you to pause the video now and try these other 3 inputs and see what you get for your outputs. Go ahead and pause. Well, hopefully you paused and had time to do that, and here we'll check your answers. How did you do? On this example, we have the function g of x equals negative 4x minus 3. Then we are given what our g of x is equal to. So we're given our outputs here. Let's do an example on this first one here, where we were given g of x equals negative 23. We're going to do like we did in last unit and use substitution. Here up is our function up here, and we know that g of x equals negative 23. So we're going to substitute that right in here for this g of x, right here. I'm going to rewrite it down here. So instead of g of x, I'm going to write negative 23, because I just substituted negative 23 in there, equals negative 4x minus 3. Now we need to solve for x. We want to know what x is equal. We want to know what our input is. And we're going to add 3 to both sides. Add 3 over here. Here's our force field. Negative 23 plus 3 is negative 20. And that is equal to negative 4x. Because our negative 3 plus 3 cancels. We need to solve for x. We're going to divide both sides by negative 4. And negative 20 divided by negative 4 is positive 5. And our negative 4 divided negative 4 is 1, so we know our x is equal to 5. So when our output was negative 23, our input was 5. That's the one we just did right here with our 5 as our answer. Here's some more. Try substituting 9 in for g of x and figuring out what x is. Try each of these. Pause your video, and we'll come back in a second. Hopefully you had time to pause your video. Now check your answers and see how you did. All right. Our next example here, our function f of x equals x squared minus 4. We are given our input again, and we need to find our output. We're given our x, and we're going to find our output here. So we'll start off. This time we're going to do our input, our x being negative 5. So I'm going to rewrite this function, but I'm going to replace my x's with negative 5. So f of negative 5 is equal to, x here is negative 5 squared minus 4. Now, these parentheses around our -5 are very important, especially when we're squaring a number. We know that -5 squared is -5 times -5. And negative times a negative is a positive, and our answer we know will be 25. -5 times -5 is 25. Well, I'll go through this way. We know that that's 25 minus 4, and we're going to get our f of -5 is 21. But you have to be very careful. If you just plug in -5 in your calculator without parentheses and square it, the calculator is thinking that you're only squaring the 5 and not the negative. So when you're doing squares on a calculator, make sure you always use the parentheses. So for this function, we already figured out that f of -5 was 21. That's the one we just did. I want you to pause the video and try with these other 3 numbers. All right, hopefully you've paused the video, and now you can check your answers. How did you do? Good, I hope. All right. Well, now we're going on and looking at functions that are represented on a graph here. Now, functions represented on a graph, we want to look for when our input is 1, for this first problem here, f of 1. If our input is 1, what is our output? Well, we know that the input is the x, the output is the y. So if we come and look, if we're going to go along our x-axis here and we go to where x is 1 right here, is there a point that's on this x equals 1 line? Yes, it is. It's this point right here. What is that point? If we were to write what the ordered pair of that point is, that is 1, and that's up 1, 2, 3, 4. That's 1, 4. So we know that at that point, our x was 1, our y was 4. So f of 1 equals 4. This is back to writing our ordered pair, 1, 4. Another way of writing that is f of 1 equals 4. Well, here we're going to look for f of 4. So we need to find out where our x value is 4. This is our x-axis, remember. And so we're going to come over 1, 2, 3, 4. Is there a point at x equals 4? Yes, this point right here. This is point 4, and it's up 1. So the point 4, 1, we can write as f of 4 equals 1. Now if we go and look for f of 3, we're going to come along our x and go over 1, 2, 3. Is there a point along this? There is not a point where x equals 3. So this does not exist. Now we need to find where f of 3 is. So on this graph, f of -3, we're going to go back -3. 1, 2, 3. Where our x is going back -3, to right here, to this line. What point's on this line? Well, what's going up? 1, 2, 3, 4. So we went up 4. So our y, our output, was 4. F of -3 equals 4. Oh, there we have our answer still. All right. Here, they're giving us the output, the y, and we need to figure out what the x is. So we need to look at where our y values, remember this is our x, f of x equals -2. Our output is 2. So we're looking at this y-axis, this f of x axis. That's how we can write f of x instead of y. But which one is going to go up or go, which one, where are we going to be at -2? we're going to be down to 1, 2. So is there a point along this line? Yes, this point is right here. This is point, if we look at it, 2, -2. 2, -2. So where our output is -2, our input was +2. Go ahead and pause the video and try the rest of these. All right. Well, hopefully you noticed that for this last one down here, there was not any point along this of y2, this f of x, where the output would be 2. There was not one there, so that did not exist. No solution, or does not exist. What about here, where our output was 4? There were 2 points along that one. So this one had 2 answers. Our -3, -1, 2, 3 was our input that had 4. And here, maybe we can even write that. This was -3, 4. And this one was +1, 4. So our output of 4 was in both of these points. So that had 2 answers for the input.